Boolean algebra. So in Boolean algebra we are using binary variables and logic operations. Boolean algebra is used to analysis and synthesis of digital logic circuits. The Boolean theorems are, so A or 0 is equal to A. That means, so these are the two OR gates. We have two outputs, we can have two different input for A is equal to 1 and A is equal to 0. So in the first one, when A is equal to 1 and this other one is 0, so 1 plus 0 is 1. Here, when A is equal to 0 and the other is 0, so 0 plus 0 is 0. That means A or 0 will always be equal to A itself. So here is A is 1, the output is 1. Here is A is 0, the output is 0. So we can say A or 0 is equal to A. And A and 1 is equal to A. Here the two AND gates, when A is equal to 1 and A equal to 0, so for A is equal to 1 and 1 is 1, when A is equal to 0, 0 and 1 is 0. So we can say when A and 1 is always A. So here is 1, output is 1, A is equal to 0, output is 0. So we can say A and 1 is always A. Other one, A plus A conjugate is equal to 1. That means when A is equal to 1, A conjugate is 0, and A is equal to 0, A conjugate is 1. So A plus A bar is equal to 1 plus 0 is 1. Here is 0 plus 1 is 1. So we can say A plus A bar will always be equal to 1. And A dot A bar, that means A and A bar is always 0. So we have two circuits. When A is equal to 1, A bar is 0. A is equal to 0, A conjugate is 1. So A dot A bar, that means 1 dot 0 is equal to 0, 0 dot 1 is equal to 0. So when A dot A bar will always be equal to 0, the output will always 0. And A plus A will always be equal to A. That means this is the OR gate. A is equal to 1 and A is equal to 1. 1 plus 1 is 1. And A is equal to 0. 0 plus 0 is 0. That means A plus A is always A. And A dot A is also always equal to A. 1 1 is 1. 0 0 0. A plus 1 is always 1. So 1 1 1. 0 plus 1 1. A dot 0 will always equal to 0. This is 1 into 0 0. 0 into 0 0. And A double conjugate is A itself. This one. When A is equal to 0, this is the first inversion. So you will get A bar is equal to 1. Again inverting, you will get 0. So A double inversion. So A conjugate will be, A double conjugate will be A itself. So A is equal to 1. First conjugate is 0. Second one is 1 itself. And A plus B is equal to B plus A. So this is AB. Just changing the input, you have the same output. A plus B is equal to B plus A. A dot B is also equal to B dot A. And A plus B plus C. This is commuting and this distribution. A plus B plus C is equal to A plus B plus C. So see, A and this is B, C and this is B plus C. So A plus B plus C, that's equal to A plus B plus C. A dot B dot C is equal to A dot B dot C. This is A. These are the two AND gate. This is BC. So A dot BC. So this is A dot B, AB dot C, ABC. So these are same. And A dot B plus C is equal to A dot B plus A dot C. So this one. B, C, this is B plus C is the output here. This AND gate. So B plus C dot A. That is equal to, this is, so that's equal to, this is AB and this is AC. So this is equal to AB plus AC. So these two circuits are same. And the important two theorems are the De Morgan's theorem. First one is A plus B all conjugate is equal to A conjugate dot B conjugate. That means A or B all conjugate is equal to A conjugate and B conjugate. A and B all conjugate is equal to A conjugate or B conjugate. You can remember these two theorems by remembering one line, that is break the line, change the sign. For example, for the first one, A or B all conjugate, you just break the line, so it will be A bar, B bar. The plus should be changed by dot, so it will be A bar dot B bar. And here A dot B all conjugate, you break the line, so it will be A bar B bar, dot should be change the sign, means dot become plus, so A bar plus B bar. That means break the line, change the sign, you will get De Morgan's theorem. So we can prove it through the truth table. I will prove the first one, second one you try. So A, B, the two inputs are 0, 0, 0, 1, 1, 0 and 1, 1. So A bar is given by 1, 1, 0, 0. B bar is 1, 0, 1, 0. So AB all bar is A and B 0, 0, its conjugate 1. Okay, 0, 0, AB is 0 into 0, 0 and its conjugate is 1. Similarly, 1, 1, 0. A bar plus B bar is 1, 1, 1, 0. A plus B all bar is 1, 0, 0, 0 and A bar dot B bar is 1, 0, 0, 0. Now look at the first one is A plus B all bar is equal to A bar dot B bar. The last two columns. So they are same. Okay, in a similar way you can prove the other.